This video is going to talk about trigonometric identities and a couple of different ways that we can use them, and a couple of ways we can use some of our older thoughts as well. Now, we know some things about trig identities. We know some things about reciprocals, such as if we know the sine, the cosine, and the tangent. Some things like the fact that the tangent equals the sine over the cosine. We can also know their reciprocal identities here. So up top, notice we've got the secant of u equals -3/2. Well, the minute that I know the secant, that means that down below here, I also know what the cosine will come out to. The cosine is just the reciprocal of the secant, so I'll call that -2/3. Now, there's lots of other identities we could use to find the other trig functions and kind of work our way through there. But because they gave us the information they gave us, telling us something like the tangent of u is greater than 0, what that really makes me think of is the unit circle and thinking about drawing a triangle in standard position. I know that the tangent is only positive in quadrants 1 and 3. And I also know that the secant is negative, or the cosine is negative, also in quadrant 3. So what I'm going to do is draw a triangle. Now, it's not going to be necessarily very accurate, but I know that my angle u here, in standard position, would have an adjacent of -2 to a hypotenuse of 3, right? Cosine of u was -2/3. Doing a little Pythagorean theorem, right? We've got the hypotenuse squared equal to the leg squared plus our other leg, which I'll just call y for now, squared. Subtracting the 4 and taking the square root, we'll find out that y equals √5. But again, we went downwards into quadrant 3, so let's call that -√5. Which again would still leave us tangent is positive. Well, tangent of u is the opposite over the adjacent, so that's √5 over 2. Having those two negatives cancel away. In that case, I can also find the cotangent. Let's take the reciprocal, 2 over √5, multiplying the top by √5 and the bottom by √5. We can get ourselves the value of the cotangent. And then finally, we also want to know the sine. So again, using our picture, opposite over hypotenuse, -√5 over 3. And again, the reciprocal, -3, it would be over √5, but again, we can call that √5 over 5 on there, right? Rationalizing that denominator. Again, we can get our trig functions or our trig identities in that way. Now, knowing those facts is great, but knowing we also have other identities is also very helpful. The main idea of this section or this video is really actually to talk about simplifying. How can we simplify statements? So using ideas like the Pythagorean identities, the even and odd identities, which I notice over here at the right. Remember that even and odd stick out because they're talking about what happens when there's that negative angle inside. Well, the secant of -x over here at the right is as good as saying 1 over the cosine of -x. And since I know that the cosine of -u equals the cosine of u, basically I can drop that negative. I'm just going to call that cosine x. On the other side over here, we've also got this sine of pi over 2 minus x. Again, that's one of those cofunction identities. You'll notice the pi over 2 minus u sticks out like a sore thumb there. And the sine would swap out for the cosine. So again, we're going to put cosine on the bottom here in place of the sine. Cosine of x is the same thing as the sine of pi over 2 minus x. So in that case, we've just swapped out a couple of equal statements, right, using those identities. Now notice again, because we got rid of that negative on the left here, right, as far as that cosine goes, that means we had cosine in both denominators. We have a common denominator, and I can actually subtract the tops. Now, taking advantage of our Pythagorean identity over here, I know that the sine squared plus cosine squared equals 1. So if I actually subtract the sine squared over to the right side, right, better put theta there, that'll only leave me, right, if that disappears, that leaves me with cosine squared theta over there at the left. Well, notice in my statement, I've got 1 minus sine squared, so that's really equal to the cosine squared of x. Now notice I didn't do that within my sort of flow of statements. I did it as sort of a side note. So if you want to make statements like that where you're going to use your identities in a slightly different way, make sure you do that as a side note, right? Keep it separate. from our other work. All right, I'm going to keep that on the side there. Cosine squared divided by cosine, I can cancel one of those away. And very simply, that becomes the secant of x, and we are done there. That large, messy statement at the top, right, just became, very simply, cosine, right? Why did I say 1 over the cosine here? Let's get rid of that. Cosine squared divided by cosine is really just the cosine of x. No need to take the reciprocal there. Oops, careful with my fractions there, right? Cancel 1 off the top, 1 off the bottom, and I'm left with cosine of x over 1, or cosine of x. Let's take a look at a couple of other identities here. Now looking at these, I see those squares right away, and I see that this is 4th power and 2nd power. I'm thinking these are great opportunities to factor. If I have a secant squared in both of my statements here, both of my terms here, I can factor that out, leaving me with tangent squared plus 1. Again, go ahead and redistribute if you don't trust that those two statements are equal. But knowing that, well, I'm familiar with my Pythagorean identities again. Tangent squared of an angle plus 1 is really equal to the secant squared of that angle. And again, I've already got secant squared. And secant squared times secant squared would really be secant to the 4th of x. Again, a single trig statement, even to a power, I don't think we're going to get much more simple than that. There aren't any parentheses to get rid of, no more like terms to combine. I think we're in pretty good shape there. Now, this one over here at the right reminds me a little bit of a quadratic. So I'm going to say, well, hey, tangent times tangent would give me tangent squared. Tangent squared times tangent squared would be tangent to the 4th. And if I think about it, multiplying to the back end here, 1 times 1 is 1. And if we go ahead and just say they're both added together, well, isn't tangent squared times tangent squared 1 times 1, and again, 1 times the tangent, 1 times the tangent squared. I believe if we add up all those things, right, you go through all the foiling, feel free to pause the video and foil that all out, but I'm pretty sure that factored nicely into our two statements there, which, by the way, are again that same trig Pythagorean identity. So therefore we really have the secant squared of x times the secant squared of x, which again becomes the secant to the 4th of x. Well, because these came out the same, technically we could say that these two statements are actually equal to each other, right? That's that old transitive property. If the secant squared times tangent squared plus secant squared is secant to the 4th, and this statement over here, right, all those tangents added up, that's secant to the 4th, well, that means these two things are equal to each other. And we've just made a new identity. Technically, if it was helpful, we'd write that one down and keep track of it. That's the last thing we're going to do with these trig identities. We want to verify various trig identities. So our goal is to prove that one side of our statement might be equal to the other side. Now, this statement here is going to take a little bit of fancy work, but the first thing I would have you notice is that we have two fractions added together, and we want to end up with a single statement. So I'm going to think about things with common denominators. In order to add fractions, we need that common denominator. Now, knowing that we've got a sine and we've got 1 plus the cosine, and I've done some of these before, so again, if you don't see it right away, that's okay, but I'm going to show you a quick little trick. 1 plus the cosine makes me think about Pythagorean identities. So I would love to take 1 plus the cosine times 1 minus the cosine, because those two statements are going to give us 1 minus the cosine squared of x. Now, in order to multiply the bottom, we also have to multiply on the top. So again, the sine of x was already there. I need to also multiply by 1 minus the cosine of x. Because if I'm going to multiply it on the bottom, I have to do it on the top. And in that case, let's go ahead and distribute. Sine of x times 1 would be the sine of x minus the sine of x times the cosine of x. Don't forget we have another fraction here. Well, in this case, since 1 minus cosine squared, what we aimed for on the left over here, is really going to end up giving us the sine squared of x. I would love to just turn the bottom of this other fraction into sine squared. So why don't we just multiply? Again, I've got sine of x. Let's multiply by another sine of x. We already have cosine on the top. But again, we're going to multiply in that new sine of x, right? I'm putting in these two statements here and here. That's equal to 1, so I can multiply by that. But in the end, that leaves us with sine squared of x and a cosine x sine x on the top. Now, because they both turn into sine squared on the bottom, we've got that common denominator. And again, I have sine of x minus the sine cosine from that second fraction plus the sine cosine. And in that case, we cancel them out. We end up with sine over the sine squared, which is really 1 over sine x, which by its reciprocal is the cosecant of x. Now, normally, again, I would work my way straight down the page. I'm not really going to worry about that right now. But what I want you to realize is cosecant of x equals cosecant of x. Therefore, QED, we've proven what we wanted to prove. All right, quid ergo demonstratum, a little Latin for us. We proved what we wanted to prove. I hope that helps you with trig identities. If you have any questions, talk to your teacher. Otherwise, have a great day.